welcome back everybody. My name is Dustin. In the last video, we finished up creating a frame buffer class and rendering our scene to this GUI window. If you have not seen that video, you can check that out right here. I've not made a video in a while. I've been extremely busy with work, family, and other projects that I've been working on. However, I'm back with this new video. So the goal for this video and for the next few videos is to actually continue with creating the little test platformer game that we were working on, and we're going to be adding in any missing functionality as we go. So in this video, we're going to start getting into states, state machines, and the state stack. I've done a video on state machines before, and I did that in the C++ text RPG series that I did. You can check that video out right here if you like. The way that we're going to handle the states in our engine is going to be done a bit differently though. However, the concepts are quite similar. So today we're going to be working with game states, like the title state, game state, pod state, menu state, the list goes on. And with these various game states, we're going to need a way to transition between the states. The transitions and other functions will be part of the state themselves. Each state will need to have these functions: on enter and on exit, handle inputs, on update, and on render functions. The on enter and on exit functions would be our transition functions for the state. What do we want to happen as soon as we enter or exit the state? That could be starting music, destroying entities, whatever that's needed for that transition. Changing the animation of a character, something like that. The on update and on render would be things that are for the state only that you want to update or control the rendering for. And then there's the handle inputs. This is basically for the actions that you want to happen when you press a keyboard, gamepad, or mouse input. Now, we could do all of this stuff in Lua. However, I want to make it a functionality of the engine. That way, the user can just create the states in the state stack if needed. We also don't want the user to have to make changes to the engine. So we want to make sure the states in the state stack are also available in Lua scripts. So for this, we're going to want to use sol function. If we take a look at this image here, this is exactly how we're going to create our states in the engine. The states will just be a simple struct, and it will have a string for the name. This is for keeping track and ensuring that there's only one state with that particular name in the state stack or state machine. We'll also be using sol protected functions for the on render, on update, on enter, on exit, and the handle input functions. If you take a look here, we're also going to have a sol object for any variables for the state. Remember, a sol object is basically just a table that we're going to be using. It can be anything, but it's most likely going to be a table in our case. There'll also be two flags for killing the state and adding the state. And we'll go over these when we get into the state stack. Then it'll also have the status function to create a Lua binding. And that is basically how we're going to define a state in the engine. We may add more later. However, this is good for now. Cool. So let's quickly go over the state stack. All right, so the state stack is exactly as it sounds, a stack of states. Take, for instance, we have a game state and we want to go to the pause state. Well, we don't want to have to recreate the game state once we are done with the pause state. So what we do in this case is we push the new pause state onto the stack. When it comes to updating the states or handling their inputs, we will only update the state that is on the top of the stack. We don't want the enemy transform to be updated or attack the player while we're in the pause state. So that's why we only want to update the top state in the stack. However, we will be looping through all the states to make sure that we're rendering each state. Sometimes you might want to show the game in the background while you are in the pause or menu state. Instead of a stack of states, we're actually using an STD vector for the states. Even though it is a vector, we'll be controlling it like a stack. The reason we're using a vector is because we cannot iterate over an STD stack, and I want to be able to call the render function on all the states that we have. We're also going to have the push and pop functions. These functions do exactly what you think. They push a new state onto the stack or pop a state off of the stack. Well, sort of. In our case, it starts the adding and removal process. However, we'll go over that during the implementation. The change state function is just a compound function that calls both the push and pop function. So it'll pop the current state unless it's empty. If the stack is empty, it won't pop anything off, and then it'll push the new state on. The top function will return the top state or the back of the vector. The update function of the state stack will do the adding and removal of the new states, and it'll also run the sol update function and the handle input function. The render should do all the rendering for all the states in the stack. So it'll loop through all the states and call its render function. Okay, so that's enough explanation for now. Let's get started with the implementation. First thing we're going to want to do is go up here and let's go into our core. In our core, we're going to add a new folder, and we'll just call this states. And in states, we'll create a new item, and we'll call this state dot h. And let's get our namespace. So namespace Scion4. And we're going to want to include sol. So include sol.hpp. Cool. And we'll just create our simple struct. And it'll be the state. Okay. So we're going to have our std string. That's going to be the name of the state. Then we're going to want to have our sol. Oh, it doesn't see sol here. So where is sol? It's probably in sol. Cool. So sol protected function right here on render. And we're going to have this default as a sol lua nil. So we'll have on render, on update, on enter, on exit, and handle inputs. You can just put these all in now. So the last one will be handle inputs, on exit, on enter, and so on render, on update. Cool. And then from there, we're going to want to have the sol object, and that's going to be for our variables. Bool nil. And then we're going to have our two flags, bool, and it's b kill state, false, and b add state, also defaulting to false. We'll go over that as soon as we start working on the state stack and how that works. Then we're going to have our static void create lua state bind. Cool. And this is going to take in a sol state lua. And we'll just go over quickly how to do it. Okay, since it's just one function, I'm not going to pull the namespace out. We're just going to leave it as is. Pretty straightforward. The first thing I'm going to want to do is grab the logger. So include logger.h. And then we're going to want to create a new Lua user type. So Lua.new user type. That would be a state. And we're going to call it state. And it's sol call constructor. Then we're going to have sol factories. And for now, we're just going to have two factories. And the first one is just going to be create a const std string reference name. So it takes in the name, and that's going to be it. So we're just going to return the state, a new state, but we're only going to set the name. So name is equal to name. The other one's going to be a bit more in depth, and it's going to take in all of our functions. So we're going to say, get our lambda function, const std string reference name, then sol protected function on enter, and we'll just copy this. On exit, go to the next line, on update, on render, handle inputs, next line. So that's all of our functions. So now we're actually going to want to have the variables. And the variables are just going to be a sol object. And that's it. So now we can open up our body. And here, return state. And it's going to be the name. On render. On render. On update. On update. On enter. On enter. On exit. On exit. handle inputs, take the handle inputs, and our variables is equal to variables. Variables. Cool. And then, all right. So now we want to do our functions. So say we use the first constructor here. We're going to want to have a way to set the functions. So we want to go set on enter. And that's just going to be a lambda. And it's going to be a state. Oh, this needs a comma here. So it's going to take in a state reference. And it's going to take in the function. Now, we can try protected function. And then here, we're going to want to check to see if the function is valid. That's the first thing we want to do. So go if not on enter valid. Then we're going to have an error here. Scion error failed to set the on enter function. Turn. And then here we want to go state dot on enter is equal to on enter. And that's it. So that's it for that particular function. Let's zoom in a little bit. So we're going to want to copy all of this and do it for the other function. Okay, so it's going to be the same thing. So just copy this, paste, so set on exit. And just make the changes accordingly. So I'm going to quickly do this for the rest of the function. All right, now we want to be able to set the variable table. Variable table. And that's going to be state reference state. Then it takes in a const sol table reference table. So I want to make sure that it's a table, not std table. So then we say if not table dot valid. We're just going to return for now. Actually, we could put an error there as well. Fail to set variable. Now, we could also check to see if it is a table. That's if we're sending in a sole object. And then we just want to go state dot variables is equal to table. Okay, and then we want to have some getters. So we want to have our variables. You can call it table or whatever you like. State variables. We need that. We want to be able to get the name. State name. And we also want to be able to get the kill state. Cool. And that's it. That's all we need for our state bindings. And from there, we can start our state stack. Might as well go here. Add new header state stack.h. Give it our namespace. Scion core. That's going to be a class state stack. We're going to have some private. We're going to have some public. Okay, and we're going to need the vector. And we're going to need the states. So include state dot h. Oh, cool. And here we can just go std vector, and we're going to have vector of states. States. That can just be default. And we're also going to have a unique pointer. Unique pointer of a state, MP state holder. Now, we're just going to be using this for whenever we need to add a state. We'll go over that shortly. Then we'll have our constructor, state stack. That's going to be default. The destructor can also be default. Then we'll have our functions, void, push. This takes in a state, void, pop, void, change state, also takes in state. Then we're going to have void, update. This takes in const float dt for delta time. And then we'll have the void render, and then state reference pop. And then we'll have our static void create Lua state stack find. So state reference Lua. Awesome. So now that we have that, let's create one of these, just so it creates our CPP file for us. Then create our namespace, Scion4. Then we can go back and create the rest of these. So just highlight everything, hit control period, go down create and declare. Cool. All right, let's go into it. So we're just going to start at the top and work our way down. Okay, so for the push function, first thing I want to do is check to see if it has the state. So I want to go auto has state is equal to std find if mstates.begin mstates.end. Then we want to have a little lambda here. I need to capture the reference, and we want to say const auto reference state, or s. Bring this down to a new line. And then we want to return if s dot name is equal to state dot name. Okay. And then here we want to just check to see if has state is equal to mstates dot end. Then we want to go has or state dot b add state is equal to true. Then we want to say mp state holder is equal to std make unique state and pass in the state. Oh, return. And if we get here, we want to say Scion assert. Oh, first thing we're going to need is add our logger. So include logger and Scion assert. And we want to get say false here. If I make it to here, that means it didn't get returned here. So that means that it did have the state and it's trying to add the state. So we'll just say trying to add a state that is already in stack. And the pop function is actually quite easy. We just want to go if mstates dot empty. I want to say Scion error trying to pop an empty state stack, and just return. Cool. And if not, we want to go auto reference top is equal to m states at the back. Then we want to say top dot b kill state is equal to true. So we're not actually doing any of the popping here. The reason for that is if we're updating the state, we don't want to kill it while it's still in the update, because it could be inside of the update function when we're calling this pop, right? Because we're going to Lua. Lua's doing everything, and it'll be doing it in the update or handle input or something, right? And we'll call the pop. Well, it hasn't left the update function for that state yet. It's still in it. So you want to wait till it comes out of the update function before you actually pop or add a state in, okay? Because especially when we're adding, because we're adding to the back. We'll be pushing back the new state, and that'll mess up which one is actually on the top now, okay? So with change state, we'll do the same thing here. It's actually quite simple. Change state, I just want to say if not m states dot empty, call pop. And we always want to call push, and that just takes in the state. Cool, that's it for change state. Very simple. See, it's just doing both for us, so we don't have to call each one individually. And if it's the first state you're changing to, it's not going to call pop, right? Which would give us an error. Well, it's not going to error out. It'll just log an error. Okay. All right. So for the update, first thing I want to do is check to see if there's a new state. Okay. So we want to go if mp state holder. So if the state holder is not null pointer, we're going to check to see if it's adding a state. And mp state holder add state. Then we'll go into here. So then I'm going to want to push back the state into the states. So states dot pushback, and this just dereference the mp state holder. So after we push back the state holder, we want to check to see if the onEnter function is valid. So we're going to go if mp state holder onEnter is valid. If it's valid, we're going to want to actually try to run the onEnter function. So we want to go try, and then down here, catch. And we're going to be catching the sol error. Scion error. That's going to be error dot what, and then just keep going. But first thing we need to do is go auto result is equal to mp state holder onEnter, and you call it like a function. And we go if not result dot valid. We want to throw a sol error. So sol error is equal to result. They want to throw the error. Throw error. The error is going to get caught right here. There we go. Cost doesn't need to be changing. And then after we make it to here, we want to set our new state holder to null pointer. np state holder is equal to null pointer. Cool. And then we also want to, if we get here, we want to go if not, or if m states is empty. Well, there's no state, so there's nothing to update. We can just return. There's no need to continue. So let's get the top state now. So we go auto reference top state using to m states dot back. Then we want to go if top state dot on update valid. So if it's valid, we want to try to update. Now there could be multiple errors, so let's just copy this here, bring this here, and change this from state holder to top state. So it runs the on update now, and this takes in DT. If error, let's add a bit more here. Let's say failed to update top state, top state. What the error is. And we're just going to return from here. We're not going to do anything else. Then we'll have another catch, just in case we have an STD exception. Copy this. And then just one for unknown. So if we made it here, we can just copy all of this for the top state. We want to handle the inputs as well. So let's change this. Handle inputs probably won't have all of this. We can just get rid of that. Failed to handle top states inputs. Change this. If top state handle inputs is valid, copy this. Doesn't need D2. Cool. I think we got it all there. All right, so we handled adding the state, and we did that up here. Now we have to handle killing the state. So we do that at the bottom. The last thing we want to do is kill the state, okay? Because say the handle inputs kills the state. Well, you don't want to kill it while you're still inside of it. You know what I mean? Well, you don't want to pop this state because it'll destroy the iterator. So we need to go back here and go if top state dot be kill state. Then we want to check to see if our on exit is valid for the top state. So we can copy all of this and check to see if on exit is valid. Do our on exit results. Cool. Failed to exit top state. On exit. Good. And if we make it to here, now we're not in anything, we're not running anything, we can actually get rid of this. Okay, so we can go mstates dot pop back. Cool. That should get rid of this state, and we're at the end of the function, so we should be okay. All right, just a couple more. We have our render function. In this one, we're just going to loop through all the states and make sure that they all are rendering. So I'm going to go for const auto reference state in m states. And here we're going to want to say if state on render is valid. Then we want to try to render it. And we will just keep running because everything is being caught. So here we'll say auto result is equal to state on render. If not, result valid. All right. So we're going to get the top. We want to go Scion assert not m states empty, not in place. Cannot get the top of an empty. So this one, if we go if m states dot empty, we're going to want to throw std runtime error, and we want to say state stack is empty, or return m states dot back. That gets us the top. Now this here will be handled in our update function. So if we're calling the top, this should be handled by the std extension that we're catching, okay? And the last one, this one should be pretty straightforward. We won't really need access to any of the variables. We'll just need the function. So we'll just say lua dot new user type. And that's the state stack. State stack. So call constructor. So constructors state stack. It just has a default constructor, so that's why we're using full constructors here. Then we're going to have our functions, so it's going to have change state, which is called change state. Push, pop, update, render, top. So top, top, render, render, update, update, pop, pop, and push, whatever that was, and push, push. Cool. Get rid of the comma. All right, that is it. Okay, now that we have to just go put these into our script system to make sure that we're actually binding it to Lua. So we'll move back to go there. Systems, scripting system, go to the top, and we'll do this down here. We'll say include states, state, and state stack. So now that we have that, let's go to our register Lua binding. We can put that anywhere in here. We'll just put it here. So we'll say Scion 4, and we'll say state, create Lua state bind, take some Lua. Then we'll do the same thing for the stack, state stack, create Lua state stack bind. Cool. Now let's just build this to make sure that it works. All right, so it looks like the build worked. Now we want to test to see if it actually does what we expect it to do. So let's go into our main.lua. See if we can find that here, main.lua. And let's comment out basically everything. You know what, we can get rid of, well, we can keep this. Get rid of all of this. Get rid of that. And we just get this closer together. Let's comment all of this out down here. Cool. And then all of this here, we can comment all of this out right here. We don't want to load anything. Right now, we just want a black screen. So comment. Cool. Everything's commented out. I guess we could probably get rid of this test data here as well for the object data. That was when we did the contact listener and started getting into physics. So we can get rid of all that. We know that works. Okay. So if we run it now, it should just be a black screen. Cool. All black. Get rid of that. Cool. And here, first thing we want to do is just create a state stack. So let's say G state stack is equal to state stack. And we'll just run that and make sure it works. Awesome, no errors. And while we have our stack, let's take it here and call it in our update function. So we're updating it. Update, that takes in DT. So that was just gonna be 0.016 for now. Then we also want to take our state stack and call its render function. Render. And we're going to run this again just to make sure those work. There should be no states that it's rendering yet, but it should work. All right, where's our... And no errors. Good. That's exactly what we want to see. So now let's create two test states so we can move in between them. Okay, so the first one we're going to make is the title state and the game state. So what we'll do is this. We will say title state. So you remember how to make a class, right? For in Lua, so we say title state index is equal to title state. And let's make game state index is equal to game state. Cool. So we'll do the game state first. So we'll just say function game state. We can say create, or you can say construct, or whatever you want for creating. And we want to take in a stack or state stack. So it takes in the stack. And here we can say local this. This is going to be our variables for the state. And we're going to have m stack, stack. Cool. And now we want to create the state. So if we come down here, we're going to say local state is equal to state, and we're going to just give it a name, and it's going to be game state. Okay. Then we want to say state set variable table, and that's just going to be this. Let's say state set on enter. And that's just going to take, that takes in a function, right? So go function and for now we're just going to say print enter game state. Cool. Now we can copy this. So we're going to want to set our other functions. So set on exit, exit game state, on update, update game state. And this takes in DT. Then we're going to have another one. This is going to be render. Render game state. And then we're going to have one more, and it's going to be set handle inputs. Set, already says set, sorry. Handle inputs. And from there, we're going to have function, and it's going to be this dot handle inputs. And why this? Because we're going to create this outside of the create function. Okay, and we're going to say set meta table this self. And we're going to want to return the state, not this. We're returning the state here. Okay. And then from the handle inputs, we're going to say function game state handle inputs. And from here, we're going to check to see the keyboard. So we're going to go if keyboard dot just released key backspace. Then all I'm going to want to do is go self.mStack pop, and then return. And cool. So there's our game state. Now let's create our title state. And the title state is going to be almost the same. So we can just copy this here. Yep. Go down, go to right here, and create our title state. So just change this to title state. Cool. It's gonna have our stack, and then you know what? Let's have our title. So I'll say m title is equal to entity title, no group. Copy this, put some commas, and then we're also gonna have press enter. Press enter. Cool. And we'll call this press enter. That's the tag that we're giving the entity. And right here, these are entities that we're creating. We're just going to give them some attributes. So let's go, or some components. So this dot m title, add component, transform component, back to 100, 100, back to 1, 1 for the scale, and no rotation. Cool. Then we'll add another component. This one's going to be for text. Text component. And I believe that takes in the font, and our default font is pixel. And we'll have this a title state, just to show that we're in the title state. Cool. Let's go to our application real quick and make sure that's the name of the font that we created. Application, yeah, pixel. Cool. So let's copy this here. M, press enter. And we'll basically be the same thing, except we'll put this at 200, and we'll change this to press enter. Press enter. Cool. So let's change the name here to title state. Enter title state, tilt title state. On exit. Now this is going to be a little bit different. So what we'll do is we'll create a function for this. So we'll say this on exit, update title state, render title state, handle inputs. Yep, we'll have this handle inputs as well. Cool. So down here we got to make two more functions. That'll be function title state on exit. And so for the on exit, I'm going to want to kill those two entities that we created. So m title, we have to go self.m title, kill. Copy this, self.m, press enter, kill. And then you can do other stuff here if you like, to do. Okay, and then we have to do our handle inputs. And for this one, we'll say function, title state, handle inputs, and then we say if keyboard dot just released. And what key should we use? I say we just use enter. Key, enter. Then Did I put then in that one up here? Yes, I did. Okay, good. I always forget sometimes to use the then and end. Just put end here now just so I remember. So if we are hitting enter, now we want to enter game state. So I'm going to go self.mStack, and we want to say change state, and we want to create a game state. So game state, create self.mStack. Cool. And then just return from here. Now, if you want, you can, this is where you would, like, say you want to load something or turn off music or something, you can do that on your on exit function. Okay, I think that's all we need to do, and let's run it. We'll fix any errors that we have. Okay, so we have a syntax error at 223. So where is that? G to 23, or was it 33? Oh, we'll find out. Yeah, right here. Try again. All right. So it's not showing anything, but are we updating anything? No, we're not. Oh, yeah. There's a reason why. So we did all this work, but we didn't actually create the state. We created the stack, we're updating the stack, but we're not actually, we didn't do anything here, right? So we need to go local title is equal to title state create g state stack. Then we go g state stack dot. You can either push here or change. It makes no difference. Let's just put change so you get used to doing that. And we want to say title, and that's it. All right, so we got an error 221, blah, 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 text component. Did we not call it text component? 221. So let's go to our text component, components, text component down at the bottom. Yeah, so we only have these have default values, so we don't need to have this entire function. We create another function, that's why we put it in a factory, and copy all this here. And then we can return text component where s font name, s font name, and s text string, so you get to s text string. Cool. So now we have two different constructors. If you want to change the padding or the wrap, you can add that in. If not, they'll just take the default value. Okay, so if we go to text component, it has default values like for color, your wrap, all these things. All right, so now we're in our title state, and we open this up. See, it's saying update and render title state. Awesome. So let's hit enter. See what happens. Cool. So we changed state, and we're doing the update and render game state just like that. If we hit exit, oh, we had to click on this, sorry. And then bang, exit game state. It did it twice, so we got to figure out why it did that. But there we go. Okay, so that's it for this video. We got the state stack going. We're creating the states. It's running the states. It's doing everything that we wanted to do. Okay, so right now, all we did was we made these states in our main.lua. So I have a little challenge for you guys, okay? Take these states here, the game state and the title state, and create new files to hold these states. So you go to your scripts. We have our test project here, and maybe create a new one for states. And create two new files in here for your game state and your title state and move them over there. Okay. And in the game state, I want you to add all of this stuff in. Load it, load the maps, load everything in. So all this stuff, the updating the player, getting the player, and setting up the player. When we go from title state to game state, I want all this stuff to be loaded in the game state. So move that over there, the collision system, everything, and have that all done in the game state. Now you can create global ones here and call that in the game state if you want. So just create it equal to nil so the name is known, right? So if you put it here and you name it nil, have it equal to nil, it'll be known, but then you create it in the game state, right? So check to see if this is nil, then create it. If not, don't create it. And then we want to load the tile map and everything. Move all that there. But don't forget, you have to run your scripts. So when you run, you have to make sure that the two new files that you create, the game state and the title state, you run those new scripts, or you won't be able to see that stuff. We basically want to move all this stuff out of the main.lua and just have this do easy stuff, easy rendering down here. Basically, all we want is our main. We want everything moved out, and we want to use the state stack and everything to run the actual state. Okay, so that's your challenge. Move these two states out of the main into their own files and see if you can load everything and have what we started with, the guy jumping around and the physics working. Okay, give that a shot. And if you have any issues with it, put a message in the comments. I'll try to get back to it as soon as possible. And I'll show you my implementation when we come back to the next video. Okay, so that's it for now. Please like and subscribe if you haven't already, and take it easy.